Bhavik Chanda, roll number 2001-02018 from EC branch, and this is my video assignment where I shall be discussing and explaining a problem based on the topic of conditional distribution and probability density function. Now let's have a look at the problem we shall be facing with. So the problem is a defective coin minting machine produces coins whose probability of heads is a random variable t, whose probability function density function is given here. So a coin produced by this machine is selected randomly and tossed repeatedly, which each successive tosses is assumed as independent. So this problem is a three-parter. So in the first part, we have to find out the probability that a coin toss results in head. In the second part, we have to find out the conditional probability density function of t. We have been given that coin toss resulted in head. And in part C, we have to find out the conditional probability of heads. Given that the first coin toss resulted in head, we have to find out the conditional probability in the next toss when head appears. So we shall be going through each part one by one. And for me, this problem is a very great example to understand the main logic behind conditional distribution and probability density function and its applications. Now we shall be going through part A, where we have to find out the probability when the coin toss is head. So I have assumed event to be A. So now if we condition this event on T, the random variable, the probability of getting head is P. So to calculate the probability PA, we shall be using the continuous version of total probability theorem, which is basically an extension of continuous distribution. And the formula is below. So you can see this is the basic formula where this is simply just the integration of probability density function to find out the area of this graph under p-axis, and basically it is from minus infinity to infinity, but here I shall be taking it from 0 to 1 because this probability density function is defined only for 0 to 1. So the probability of A is equal to integration of 0 to 1. This term applies to probability whenever the probability of getting head is P. So we have to find out the coin toss probability, which is equal to P only, and FTP is given in the question. So substituting the value, you can see this only fall down to this simple integration. So integration of 0 to 1 p square e to the power p dp. So this integration can be easily find out by integration by parts. Now I have assumed as u is equal to p square, dv is equal to e to the power p dp, the two parts of the integration, and I have into u, so du I can find out, and dv, so we can find out. So integration by parts is basically just this formula. So integration of u dv is equal to uv minus v du. Now substituting the values of u and v, as you can see in the first term we have to substitute 1 minus substitute 0 minus the second term, and there is again integration, and we have to again apply integration by parts. So you can see the first part is uh, substituted to e, and the second part is fallen down to these two terms, and the second term is also integration part, which can be easily calculated, and by substituting all the values at the final result we get that the probability of A is equal to e minus 2, which is equal to 0.718. So therefore the probability that a coin toss results in head is 0.718. So the part B, we have to find out the conditional probability density function of t given that the first coin toss is head. So we shall be using a very basic rule, which is base rule, and we shall be using the continuous form because t here is continuous. Now this is the formula. So the LHS stands for the probability density function of t whenever A is conditioned, and this is basically just slicing of the area of the basic conditional probability density function. So PA when t is equal to P upon PA, this is basically fraction slicing of this conditional probability function to get a new probability density function. So substituting the values, we have this P, this is from the question, and this we have calculated from E minus 2. So this is not the final answer because this is not valid for all values of P, this is valid for 0 to 1. And for other values, it is 0 because FTP is also only defined for 0 to 1. So the final answer is this in right side, as you can see, P square e to the power P upon E minus 2 whenever P belongs to 0 and 1 and 0 for otherwise. Now so we will be finding part C, we shall be finding the probability, conditional probability of next coin when it's head, given that the first coin we have found is head, and this is just the combination of part A and part B. So I shall be assuming X be the event that the next coin result in head. So this is again the same formula is first problem 1, but here I have seen that this is using the probability density function of part B. As you can see, the first term there is a term of A also, because this probability is we shall be taking A also in account. But here, as we assume that it is an independent event, we can easily here, remove the A part. So as we have already calculated PA, due to independency of toss result, the first term can be reduced to this term. And this is simply first time basic substitution and integration. Now you can see this is the integration. I have put down the values of P and P square e power P, which is upon e minus 2, which have been found in form second part. And then again applying integration by parts. Now I am getting value of 6 minus 2e upon e minus 2. Now you can see this is the final answer. This is the conditional probability of second coin toss head, and therefore the conditional probability on of head on next toss after first toss is head is 0.7844. So all three problems have been discussed, and thank you.